So to do number 25 in chapter 9, you're given that the radius of the petal, okay, is 0.1016 meters, and basically I took the 8 inches divided by 2 for 4 inches, multiplied the 4 inches by 2.54 centimeters per inch, and then moved the decimal to get the meters. I did the same thing for the gear here, so the radius of the gear is 0.0381 meters. Okay, so I have this gear and this gear. I really don't care for this question what the radius of the actual tire is, because it wants to know what the angular velocity of the pedal is going to be. They're giving you what the angular velocity of the gear is. The angular velocity of the gear is the same angular velocity of the tire. We know that the linear velocity of the chain is going to be the same throughout. So the linear velocity of the chain is the tangential velocity of the small gear. So here I have the tangential velocity equals the radius of the small gear times the angular velocity of the small gear, and they're telling me that I want a 75 RPM, which is the same thing as 7.85 radians per second. So I multiply the radius of the gear times the angular velocity of that gear to get 0.299 rads per second. That is going to be and I'm sorry, that's not rads, that's meters per second. Meters per second, and this is rads per second. The 0.299 meters per second is going to be the tangential velocity here. So 0.299 meters per second equals the angular velocity of the pedals times the radius of the pedal, which is 0.1016. So I get an angular velocity of 2.94 radians per second.